Hello, in today's video we will learn callback promise and async-await all on the same page. By all on the same page we essentially mean that we eventually have a program that will be having callback promise and async-await. So the plan for today is first we will create an asynchronous operation. This asynchronous operation can be as simple as setting a value of variable x. Then we will make a call to this asynchronous operation using callbacks, and we will learn that using callbacks to make a call to the asynchronous operation can get us into a problem which is called callback hell. So to deal with this callback hell problem we will be using promise chaining, and we ultimately will learn that async-await is a way much more promising than using promise itself.
We will create our asynchronous operation. So for that, first create a variable and initialize it to 0. Then we will create a function with the name transact, and inside this function we will do a set timeout. And why set timeout? Because we want to give an asynchronous flavor to this function. So inside set timeout we know the first parameter is a callback and second parameter is a time in milliseconds after this callback will be called. And inside this callback function let's set this x to 1 and then console.log this x. And finally you will have to make a call to this transact to execute it. But let's suppose I want to give more randomness to this asynchronous function, because asynchronous operations, they are random in nature. You cannot predict how much time this function will take to execute. So let's create a random variable, random equals to math.floor and math.random into 100. So what this math.random into 100 and math.floor operation will do, it will return a random number from 1 to 99 and it will save it to the variable random. And here instead of 1000 I can write this random variable. So this callback function will be called sometimes after 100 milliseconds, maybe sometimes after 50 milliseconds. So that's quite random in nature. So this is I can say this is a pretty well asynchronous operation. Let's tweak it a bit more. Instead of just setting the value of x equals to 1, let my user decide what value they want to give to the variable x. So for this we will have to have a callback variable here, and inside the transact the user will have to say what value they want to pass to x. So here suppose the user says that x equals to x plus 1. Instead of giving it a value, just increment the value of x. So from 0 this user will increment the value of x to 1, and he would also like to give his name. Let's suppose this name is 1 along with the updated value of x to be printed on the screen. Okay, so this is, let's check the curly braces and parentheses. This is the set timeout function closed, and this is transact function close. Okay, so let me do one more thing. Let's call this transact one more time. So we have a two call to transact, one from the side of A and another from the side of B. So the result should be like the x value should be updated from 0 to 1 by A and then from 1 to 2 by B. We still have this console.log there, so what, and x equals to 1 there. So what we want to do here, we will make a call to the callback, and let's check. Here first A's operation is visible, then B's operation, I mean the first transaction from A is there, then B is there, again from A, then B. Oh, this time you see first the transaction from B occurs and then from A, again from B, and again from A to B. So we can say that when we call this transact method in this manner, we cannot say for sure what transaction will occur. But in sometimes in real life you may have a condition that transaction from A client should occur before the transaction from B client. So to achieve this result we will have to cut this transact call from here and paste it over here. And let me do a little bit of indentation, and now you can see, if you can look at this mouse pointer, this kind of structure is a typical pyramid structure, and therefore this is called pyramid of doom. This is also called callback hell, which is a very important and very devastating maintenance issue that JavaScript coders and programmers face. So let's check our output first, whether what is the output. So first transaction from A occurs, then B, A, then B, A, then B, A, then B. I think it works. Yes, it works. So this is our solution if we want that transaction from A should occur first and then the transaction from B should occur. Okay, so but this kind of code pose a problem of callback hell. So how to get rid of this problem? To get rid of this problem, we have the concept of promises. So to convert this code into a promise code, we will have to tweak this function. This function will now return a new promise object, and you know that promise takes two variables, resolve and two parameters, resolve and reject. And here, this is the promise, every other thing will be inside the promise, and here this callback is called inside a resolve. So we can say that when this function transact will be called, it will return a resolved promise. Okay, and we know that whenever a promise is resolved, the then function is called. So here first we will make a call to transact that I am making in this code. We are calling transact with x equals to x plus 1 and console.log a, and after this transact call, a promise, a resolved promise will be returned. So here we will have a then function, and then again takes a callback, and inside this I am again incrementing the value of x and writing console.log, hey, this is b and this is my value of x. So this is my promise version of the same callback code. So let's check the result. Oh, this is 1 and 2, 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 1 and 2. I think it works. Okay, so if you look at this function, this version of my earlier program, you will see we are using then. Suppose there were more transact calls, then we would had more than right there. So this then type of code is actually not very soothing to the eyes, and even it's not very kind of say this is a very good approach to write promises, although this is a good approach in comparison to the callback calls, which ultimately lead to a problem called callback hell. But definitely using then in so many times, we actually have a very good approach than using promises, which is called Async-Await. So let's convert this code into using Async-Await operations. So for this I will have to call a function over here, and these transact call I will have to put inside function, and we don't need any then. In fact, I don't need this code there. So what I'm doing, I'm just calling this function right there where I'm executing this. This is called callback. This is called self-invoking functions. So this is my function, this is my transact call. Let's do it one more time. So now we have two call to transact like we had earlier, and this time not from A but from the side of B. And let's tweak this function by adding a keyword async. So I'm just declaring that this function is an async function. Oh, it's not async, it is async. And here in the transact part I will put an await keyword. Now what is await will do? It will instruct my JavaScript engine to wait from executing this script until this promise is resolved. Okay, so let's check this once again whether, oh, there is some error. Oh, I know what this error is. I have to put a semicolon before here. Otherwise, this function will assume that this left parenthesis, this is actually some kind of function arguments. So once we have saved it, and let's check that. So when I see the result is 1 2 1 2 1 2 1 2 again, so I think it is working. So Here I can rest my case. Thank you.